Hey, what's up guys? I'm back with another game that we're going to create with Flutter from scratch. And the game we're going to clone this week is called Bubble Trouble. Now, if you've ever played this game before, then you would have probably played it on the web through the browser. You could technically make this into a mobile game if you like, whether it's landscape or portrait, but I think it's probably more appropriate to create it using Flutter Web. So if you open up a brand new Flutter project, this is what you should see. And under this main function, let's delete everything below it, and we're going to create this game completely from scratch. Let's create a stateless widget first off, and this is where our material app is going to be. Now let's check off some of these options. So the first one is to turn off the debug banner, which is this thing up there. And for the home, let's call it homepage. Now let's try to keep our code as clean as possible, so let's create a new file called homepage.dart. Make sure to import the material.dart file as usual. And for this one, instead of a stateless widget, we are going to make a stateful widget, as this game is going to have a lot of moving parts. And let's call this homepage. Now if you come back to the main.dart file, you should see a red squiggle. So click on this little light bulb and import the homepage file we just created. Cool, let's close the main file and start building our UI here. Now the first thing to do is to not return a container, but instead return a column. And in this column, our children are going to be two expanded widgets. If you've seen any of my other games, you know I always love to do this at the beginning. And just to show you guys, let's put in some colors. This top container can be pink with a strength of 200, and the bottom one can be gray. Now if you don't already know what an expanded widget does, we have this column, right? And so instead of setting a fixed height for these containers, an expanded widget will expand the container to fill the rest of the space. So if you have two expanded widgets, as you can see, it will split the screen into two halves. But what I actually want is the top part to be a bit bigger, so you can specify this flex property to say 3. If you don't specify the flex, it will default to 1, as you can see there. And so what this means is the ratio is going to be 3 on the top to 1 on the bottom. And this pink, let's actually make it a little bit lighter. Now our plan is to have a row of buttons on this bottom portion and our game in this top pink section. Let's start with the buttons. Now in this row, we could start coding up our button right here, but instead, let's encapsulate this bit of code to make our homepage look cleaner. So create a new file called button.dart, import the material.dart file, and let's create a stateless widget called myButton. This way we don't have to repeat the same code many times. Let's give it a width and a height of 50. And for now, let's make the child just some text widget just to see what this looks like. And finally, let's give it a color as well. So now we can come back to our homepage, and inside the row, we can insert my button. And you can see it showing up. A few Flutter updates ago, they made it so that you can press tab to auto import the file. But if not, you can always click on this little light bulb and import it manually if you see the little red squiggle. But yeah, that's a nice little handy tip to use. Let's save this and see what this looks like. There it is, and now let's add a couple more buttons. Now the next thing to do is to change the axis alignment to space the buttons out. Let's go to our button and center the child, and instead of returning a text, let's return an icon. Now, one of the icons we can use is arrow. Hopefully we get some options. Let's just use the first one, see what that looks like. For the container, the corners look pretty sharp, so let's wrap our container with a widget called clip rect, which stands for clip round rectangle, and this will make our corners round. So we'll have to specify this border radius property. So if we rebuild this, you can see it makes the buttons look much more nicer and cuter. The other thing is, obviously we don't want them to all have the back arrow, so we're going to create a little constructor. So let's create some variables here, and this is the constructor. So instead of hard coding this icon, we can assign it to be whatever icon we pass through when this button gets created. You can now see the option to specify an icon inside the button, and this is what we created over here. Okay, now what icon should we pass through? Well, the first one is the back arrow, the second one can be arrow up, and the third one can be arrow forward. So what we did just then is called object-oriented programming, where we can create this button object so that we don't have to rewrite this code multiple times, and work in a much more cleaner way to encapsulate most of the button code in a different file. So far so good, but while I'm at this button class, let's add another feature here called function, which we're going to need later on, because if you click on these buttons right now, they're not really doing anything, they're just sitting there looking pretty. So what we want is for something to happen when we tap on these buttons. To do this, let's wrap the button in a widget called gesture detector, which does exactly what it sounds like. It detects a gesture, and the gesture we're going for is a tap. So on tap, let's execute the function. That's pretty much it for the button. I don't think we need to tweak this anymore, but we'll see how we go. Now if we come over to the top section, which is this pink area, let's add a little character that we can move around. The key widget to use here is a stack widget, and what a stack widget does, as the name implies, it stacks widgets on top of each other. So we definitely need a player, but we also need different balls and things like that to jump around. So we want many different widgets in the pink area, so that's why we're using a stack widget. Let's start off with a container whose child is another container. And just to test this out, let's set the height and width to be 50 with a random color, say blue. And let's see what this looks like. Okay, good. Now one thing we can do is use the alignment to position this blue container anywhere on the screen. So for example, let's say alignment 1, 0 and rebuild it. Cool, so the way these alignments work is to consider two different axes. So if you look at the horizontal axis, it's -1 on the left and +1 on the right. Same thing for the vertical axis. At the top it's -1 and on the bottom it's +1. So if we put 0, 0, it should be in the middle. Similarly, if we put, say, -1, -1, it should be on the top left corner. So using this coordinate system, we can position things on the screen wherever we want. So for the player, we want him to be on the ground. So for the y-axis, that's going to be +1. And for the x-axis, let's put him in the middle. Now the cool thing we can do here is, first of all, make this a bit prettier. Let's make these corners rounded. Border radius dot circular, let's say 10, and change the color to purple. Later we can grab a nice image to replace this square, but that's just for looks, so I'm just going to use a square now so that we can focus on getting the mechanics of the game down first. And so the first mechanic we should implement is the ability to move left and right. So if I want to move left and right, that means this 0 shouldn't be a hard-coded 0. It should be a variable that we can control. So I'm going to call this player x, which I just mean the x coordinate of the player. So let's come up here and create some variables. Double player x equals to 0. And so this way, instead of hard coding 0 as the position, we can create a variable that's called player x, which is 0 initially, but later we can control this particular value to move the player around. For the y coordinate, I think it's fine to hard code it as 1 since this game doesn't involve any jumps. So the player should always be on the ground. So we will just move left and right, and this up arrow is for shooting a missile that you can fire. Cool. Now, how do we actually move this player around? We need to create some methods. So let's go void move left, void move right, and while we're here, let's also create void fire missile. So I have these different methods, and they will get triggered when we tap on these buttons. So if I hit the back button, the function we will pass through is move left, middle button is fire missile, and the last button is move right. So if we tap the left button, let's set state and move the player a little bit to the left. Remember, -1 is here and +1 is on the right. So if I subtract, it should move us to the left. Same thing for the right button, we will move a little bit right, so let's change this to a plus. I guess I should also mention here, if you're not familiar with this notation, it's the same thing as saying player x equals to player x minus 0.1. So player x is whatever you were, subtract 0.1. But a nice shorthand way to write it is this. Okay, now hopefully if I save this, we should be able to move the player around. And yay, we can start moving left and also start moving right. So obviously, depending on these numbers, like if I said 0.5, this is going to be too big of a jump, because if -1 is there and +1 is here, we don't want to be moving in 0.5 increments. That's too much. So this is where you can fine tune the movement. Now, if we come back to our stack, remember on this homepage, we want to make it as simple and as readable as we can. So similar to how we made a class for the button, we're going to do the same for the player. So let's create a new file called player.dart, import the material.dart file, and let's just copy this in. Create a stateless widget called myPlayer, and let's paste what we copied. Looks like we have a red squiggle under this variable because we created that variable over in the homepage, right? So in our player.dart file, we are going to need to create a constructor to pass this variable through. Let's say final player x and create the constructor. So if we go back to the home page, and in the stack, we can now insert my player, and there it is, tab to import. And inside, we should have the option to pass the player x variable through. So hopefully you followed what we just did. A little bit of file management and some object-oriented programming can help us code this much easier. Now I just realized one thing, our purple square corners are still not round, which doesn't matter too much because this is going to get replaced with an image anyway, but I'm a bit OCD like that, so this is bothering me a tiny bit. So let's remove this clip our rect widget, and we're meant to put this on the second container down. Another important thing is we're aiming to make this game so that people can play on their laptops or desktops rather than mobile. So realistically, we don't want the user to be clicking on the buttons with their mouse, but rather we want the user to be able to use the keyboard. So let's come to our overall column and wrap this with a widget called raw keyboard listener. And in here, we need to put in a focus node and some properties we need to make true. And I think I have one more to do. Yes, it's the on key one. Raw event key event. So what this does is it listens for the particular key that the user is pressing. So I'm just going to copy this part in, import the necessary library. I think we can actually just delete the event type. So if we tap the left arrow on our keyboard, let's trigger the move left method, and same thing for the move right. So you can still of course tap on these buttons to move around, but now you can also just use your physical keyboard to move these around, which is more practical. Last one is let's just copy this guy, and if we hit the spacebar, then we can fire the missile. The next thing is if we continue going left, we will go off the screen. So to prevent this, we want to make sure we don't want to go further than -1 when we go left. So let's add a simple if statement. Similar to moving right, make sure we don't go further than +1. And let's see if this works. And nice, it does. Now it's finally time to fire the missile. If the missile gets fired, let's add a timer with a duration of 100. And in here, let's have a ball. So let's come over here to create some missile variables. And in our stack, let's create a container with a width of 30 and a height of 30 and a red color. And let's wrap this with another container to set the alignment for the X and Y coordinate for the missile. So if we fire the missile, let's increase the missile Y coordinate and let's see if this works. Whoops, we want to go upwards, so we should subtract actually. Cool, so it looks like that's working. Now, one thing is when we go back to our stack, the bottommost widget is the one that's closest to the front. So let's put this container behind the player. If you've ever played Bubble Trouble, the fire weapon is actually not a missile that fires like this, but rather we want a string that goes to the top. So instead of just changing the Y coordinate, let's actually change the height. Oh, it looks like it's growing, but really slowly. So let's change this to 10. Alrighty, getting closer. Let's make this grow faster. And change the width to be smaller, and let's change the color to gray. Yay, it works. I think we can make the width even smaller actually. Now, one thing about this is we actually want the missile to fire from where we are, but right now, even if we move somewhere else, it will still fire from that position. So let's come to our variables and set missile X to be player X. Oops, looks like I have one too many set states. Every time we move right or left, we want to make sure missile X equals to player X. Now when it comes to firing the missile, we want the missile to stop once we reach the top of the screen, right? So if the missile height is greater than the height of the entire screen, then let's cancel the timer. The reason why we have 3/4 is because if you remember from the start of the video, we made the pink section 3 times larger than the bottom gray section. Once we cancel the timer, we also want to reset the missile. So let's create a new method for this. It looks like the position of the missile is slightly off. We should put this code here on the bottom of the method actually. Cool. Now we're getting closer and closer to the desired result. We can clearly see what the next problem is. Once we fire, we want the missile to continue firing from that position instead of following our player during the shot. Just before we fix that though, let's encapsulate our code again. So copy our missile code and let's create a new file called missile.dart. Let's call this stateless widget myMissile and copy the code here and create the necessary constructors. Let's clean up some of these variables, like we don't need the missile Y coordinate. Awesome, so returning back to our problem, we definitely want the missile to be fired from the player position, except when it is in the middle of a shot. This calls for a Boolean variable. So if we hit fire missile, it's only going to fire if mid-shot equals to false. If the timer does start, then let's make mid-shot equal to true. And you know what? Let's just separate this out and comment it. If we do reach the top of the screen, then the missile is finished. So let's say mid shot is now equal to false. So if we come to our methods again, let's make it so that the missile X equals to player X only when it isn't in the middle of a shot. So what does that mean? It makes it so that the missile doesn't follow us during the shot. Rather, it continues from the position it was fired in. Awesome. So now let's create a ball for us to pop. Come to the top and create some ball variables such as the X and Y coordinate. And let's create a new file called ball.dart. Name the stateless widget myBall, and this is where we will code the ball up. Now let's insert the ball into our stack and see how it looks. Looks like it's in the top left corner. So let's go back to our ball.dart file and wrap it inside another container so that we can control the alignment. And while we're here, let's make the ball a little bit bigger. Also, we need a play button down here. So come to our row at the bottom and create a new button, and the icon can be a play arrow. And the function is start game. Let's create this start game method. And if this button is pressed, let's move the ball a little bit. Now let's test this. And it looks like it did move a little. Let's do this with a timer so that it moves constantly. Damn, that was super fast, so let's reduce this number. Now as you can see, it's just moving off the screen. So we might need a sense of direction. So let's come up here and create an enum called direction. And basically enum is just a list of options that we want to use. So for example, inside the start game method, we can reassign the direction if we hit the walls. So first let's create a variable called ball direction, and initially set it to go left. Now if we are about to move off the left wall, change the direction to right. If we touch the far right side, then change the direction back to left. Then we can say, well, if the direction is left, then let's move left, and if the direction is right, then we can move right. Let's test. Hopefully it just goes back and forth. Please bounce off. And there it is. Sweet. Now we need to try to pop this ball when our missile hits it. Since we know the coordinate of the ball, we just need to check if the coordinate of the ball is the same as the coordinate of the missile. However, we don't know the coordinate of the missile, we only know its height. So what we need to do is to come up with a way to convert a height into a coordinate. Now the goal here we are trying to achieve is to convert a height into a coordinate. Or more accurately, it's an ordinate really, since we're only looking at one y-axis. But basically we're just trying to convert a height into a position. Now remember, it's -1 up here and +1 down the bottom, which means 0 is going to be in the middle. Now if you take a look at this black ball, it's going to have a certain height above the ground. And we can find its proportion to the total height. Now to find the total height in regards to the code, we're going to use the media query. And if you remember from the start of the video, we made the top part 3/4 of the entire screen. So let's multiply it by 3/4. Let's actually call this position to be more simple and clear. So to find the equation for the position, first of all, we're going to need the proportion of the height over the total height. So whatever the proportion is, we're going to subtract it from +1. And the other thing is, since we're not going from 0 to 1, it's actually -1 to +1. Let's just multiply the fraction here by 2. Now let's test if this formula works by substituting some values. So let's test some easy values. Let's say the ball is in the middle, then the fraction of this height to the total height should be half, right? And hopefully this gives us a position of 0. So if we just sub these values in, we can do a little check. So position equals to 1 minus, we said this fraction should be half. And let's just simplify this down. So 1 minus 1, which equals to 0. And of course, that's the position that we're looking for. So this formula is indeed the correct one that we need. And now let's implement this into our code. So this is the equation we just derived. Now let's write some comments here to detail what this function does. And to reiterate, this function takes in a height as an input and does some math to spit out a position as the output. Let's re-comment these to make it a bit more clearer. So stop missile when it reaches the top of the screen. And below it, we're going to check if missile has hit the ball. So if we hit the ball, we want the ball y to equal to 5, which just moves it off the screen. And of course, let's cancel the timer. Now in this if condition, if the ball y is greater than the missile height, what this means is height to coordinate of the missile height will give the position of the tip of the missile. But in this game, the ball pops not only when the tip of the missile hits it, but also if any part of the missile makes contact with the ball. So any part that's below the tip of the missile as well. We also need to check if the x coordinates are the same. Now it's tempting to just check ball x is equal to missile x, but if you have any knowledge about doubles, it often rounds numbers, so these two values may never actually be 100% equivalent. So what we need to do is to take the difference between the two values, absolute value them so that we are just looking at the difference, and check if this difference is below, say, 0.3, which is just an arbitrary number of your choice that basically represents the small margin of error that we are willing to accept. Let's also make sure to reset the missile. Sweet, now let's see if this works. Cool, so we can now hit the ball. Let's take some time to add some comments here. Currently our ball is just moving left and right. So let's comment this out for now, and instead of just moving left and right, let's try to make the ball bounce. For this, we are going to need to create some new variables. One of them is time, and the other is height. Now the equation that models a jump, if you recall from high school math, is an upside down parabola. I have used this equation in many of my previous projects such as Mario, Flappy Bird, MapleStory, and all those games. We need to update the y coordinate of the ball using a set state and keep the time going. And let's also start the ball on the ground. Let's test this. Cool, looks like it works. but it's moving really slowly. So let's make this duration faster. Much better. But one problem is it continues to drop past the ground. So let's try to prevent this from happening. So let's say if the ball reaches the ground, reset the jump. Now the height is how high you are from the ground, right? So let's check if the height is less than 0, meaning it's below the ground. And if that happens, then let's restart the jump. Awesome. You can see how smooth it is and it reenacts a real jump. That's because we are using this quadratic equation, which is how many objects jump in our physical world, that is the Earth. One thing we can do is change this velocity to be weaker. Maybe we could just make a separate variable for this velocity. Now we can uncomment this, which just makes the ball move left and right. And see how that looks. Looks like a very funny bounce. Let's move this time to the bottom. And let's change this to 0.005. In other words, make the left and right movement much smaller. Let's try to comment on everything and clean some things up. Both of these resets the missile, so let's move this mid-shot equals to false into the reset missile function. For some reason this isn't working. Let's actually change it to an x coordinate. Now, one thing about this height to coordinate function is that it's not only useful for the y-axis, but it should also work for the horizontal x-axis. So let's rename this to position. I think that's more appropriate and clearer to understand for this context. We need to use this function to check if our player dies. So let's create a Boolean function. Now the player dies if the ball touches the player, right? So if the ball position and the player position are the same, then the player dies. In other words, in code, if the difference between the ball and the player is less than 0.05, then return true, otherwise return false. But this is only checking the x coordinate, so let's check the y coordinate also. Let's say if ball y is greater than 0.95. Now we can fine tune this number, but let's see if this basic idea works. Let's add this to our start game function. So check if the ball hits the player. If player dies, which is a boolean, so it will return true or false, cancel the timer and print dead. Cool, so it looks like it works. Now instead of just printing to our console that we are dead, let's show a dialog screen. So I'm just going to copy this in and let's say, "You dead, bro." Sweet. Let's just decorate this a little. And there we go. Okay, that's basically the main mechanic of this Bubble Trouble game. So getting a ball to bounce and shooting it down with a missile. The next few things to add is perhaps a button on this dialog screen to restart the game, and replace this purple box with an image of your choice, both of which I've shown many times in other games, so I'm just going to leave it at that for this tutorial. Looks like this video is pretty long again, and I'm going to try to aim to keep it under an hour if I can. I hope you found this interesting and helpful, and let me know if you have any questions, of course. Now it's time for me to go back to the lab, and I'll be back next week with another game. Peace!